All right, we are back and we've been working on Mancala. In the last video, we added this constructor that'll take in an integer array. The main thing there is to use it for testing. We can actually provide it basically a board state. Right, here in this example, I'm creating a board that's using an initializer list to kind of set up an initial state. I then pass that in, and that's how our Mancala game begins. Again, it's really good for testing. And speaking of which, I was testing the get winner method, but I realized like as soon as I stopped recording, there's one scenario I did not test. Let's take a look at get winner for a moment. Right, the idea is we're going to check to see if the game is over. If it is not over, there's no reason to even see if there's a winner. Right, we just return a -1 value. However, if I reach this point, the game is over. I know this because I'm still here. The game must be over. Okay, here we see the get seeds method being used. That's another one that we wrote in the previous video, where it gets the total value of the smaller seeds, and then we're going to tack on the player's Mancala, because ultimately the way we determine who the winner is if the game is over, and then whoever has the most seeds from there. I'm saving these values into some variables, basically just to clean up my code, because here's a simple check to see if 1 is greater than 2. That must mean that player 1 has won the game. The game is over. If 1 is greater than 2, then player 1 must have won. If 2 is greater than 1, well, that means that the game is over and player 2 won. Okay. Notice that these variables, A, clean it up, but B, right, I would use them twice. If I did not use these variables, I would have to basically do this 2 different spots, here and here. I would have to do this in 2 different spots, here and here. So not only is it a readability thing, right, and I clean this up, I get cleaner code, but it's actually more efficient because I would be calling get seeds an unnecessary amount of time, just 1 extra time, but it's still unnecessary. So we do get some efficiency here. The scenario I did not ultimately test was a tie. What if the game is over, but they have the same amount of seeds? Okay, so that takes us back to our driver where we have an initial board state where the game is over. In this particular case, player 1 can't make any more moves, so the game is over. But we need to basically total up the seeds for player 2 as well as player 1 to see who actually won the game. In this particular scenario, we had it where player 1 was winning, but I'd like to test where we have a tie. The game is over, right? Player 1 cannot make a move, but they have 21 total seeds compared to player 2's 21 total seeds. Right, so we're going to test that out, and our get winner should, in this case, return a 0. And if we want to test a tie in the opposite direction, it's very easy. I just kind of flip the board. Right, now player 1 has all the seeds. Well, all the seeds in the smaller pits. Player 2 cannot make a move, yet this is a scenario where there is a tie. So I wanted to show that. So we end up using get seeds here. We also use get seeds here in our game over method to quickly determine is the game even over. And so that's why the get seeds method exists. Now, it almost lends itself to be a helper method. I'm using it in multiple spots, which justifies the existence of the method. However, right now it's only in mancala.java, which kind of seems like it should be a helper method. You can make it private. As we're going to see a little bit later on, whenever I go to kind of display a final score to the user, I'm going to need to be able to basically get the seeds or something of that nature. We could maybe make it like a get score method if we needed to do that. But to be fair, our examples of Mancala on the internet where you play it, when the game is over, they don't tell you the score per se. It's kind of just like a visual thing. I could be wrong with that. Anyway, I say all that to say that this could be private, maybe. It's also fair to just leave it as public. One thing I did not do here is I talked about a alternative approach to this method where we basically do the loop just one time, and the only thing that's changing, depending on if it's player 1 or player 2, is where you start and end that. I talked about that solution but did not actually program it, so I'm actually going to do that real fast. Where effectively the loop, along with the summation of the board, was effectively the same. The only thing that was realistically changing, depending on player 1 and player 2, was where we start and where we end. So let me extract this out, what I would deem the duplicate code, and instead what our if statement is doing at this point is setting the values basically for where we start and where we stop. So I'm even going to create those variables. Int start is a position, right? Right away, if we set it to 0, that's kind of awkward. One thing that we could do is basically assume one of the players and then look to change those values. Let me show you what I mean. Okay, let's assume that it's player 2. I've already got this here, which is why I'm assuming player 2. Let's assume player 2 is who we're trying to get the seeds for. Well, when it's player 2, the starting position is player 1's Mancala +1. Okay. The stopping position is player 2's Mancala. Okay. So I'm going to assume that it's player 2 initially. I'm going to quickly perform a check. If it turns out to be player 1, I'll change these values. Right? So if the player turns out to be player 1, the start position is going to be essentially this stuff down here. Right? The start position is 0 instead. The stop position is player 1 Mancala instead. So what that means is when I get down here to my actual loop, what I'm doing is changing where I start based on the variable and changing where I stop based on the variable. So this is the alternate approach I was talking about, which comes from recognizing that effectively the loop is doing the same thing. It's just going from start to finish, from start to stop, incrementing. And then we're just finding the summation of that in the meantime. So the way this is set up, I effectively don't need an else because I'm assuming player 2 initially. But if it turns out to be player 1, I change the values. Regardless, we're going to go from start to stop. And if I just run my code, what we'll see is that we're getting the exact same results, which means our get seeds is working as intended. So that is the alternate approach I talked about and the one that I wanted to show you. Now for the meat, which is the move method. Okay, let's pull up our documentation, and I'm going to pull up some reference code because this is the challenging part. Please forgive me for not having this ready to go. Okay. All right, here's our Mancala project. Let's look at the move method there, and then we'll actually start coding it. It was worth 20 points out of the 50. So as you can imagine, that was a large chunk of your points because that was really the hardest part of this whole thing, was this move method. Let's take a look. Mancala's move performs a move by removing all the seeds from the specified pit. Right, so we're passing in an integer. That is the pit that we want to move. Then distributing them one by one into subsequent pits. Note that seeds should be distributed into the active player's Mancala in the enemy pits, but not the enemy Mancala. This is my first big tip when talking about this, is stop thinking about player 1, player 2. Don't worry about that. Think about it in terms of active player and enemy player. If we add that layer of abstraction, this actually becomes easier. Big hint, the active player can be determined based off the specified pit, right? We're going to be passing in some type of integer. And depending on what that integer is, you can determine who must be playing, like whose turn it is, who the active player is. What am I looking for? Mancala? Oh, here comes the sound. I remember this time. Okay, these pits belong to player 1, right? 0, 1, 2, 3, 4, 5. So, yeah, and 6 is their actual Mancala, 7, 8, 9, 10, 11, 12. Right, so if I give you the number 12, right, if I say move pit 12, you know that player 2 is the active player because that's who that smaller pit belongs to. If I say move 3, we know that we're moving pit 3, 0, 1, 2, 3, that's this one. It belongs to player 1. So that is what the hint is saying here. You can determine who the active player is based on the pit that we're trying to move. Move should perform and execute a capture. This is going to be one of the harder parts. A capture occurs if the last seed being sown, blah, blah, blah. Why don't we come back to that? All right, let's worry about doing a move. We'll worry about a capture later. Move returns 1. Right, notice we have a return type. If player 1 should go next, or 2 if player 2 should go next. The active player should go again if the last seed being sown is distributed into his or her Mancala. Otherwise, the enemy player should go next. Okay, so that's what this return type is. Let's get a method header in and let's get started. I am back in IntelliJ. I'm going to plug in the move method. It doesn't really matter where. But public int move takes in an int. I'm going to call that pit. That is the pit that we want to move. And let's Java doc this one because you know it is hefty. Here we go. Performs a sowing action, a move, by removing all the seeds from the specified pit and distributing one seed in each subsequent pit, including the active player's Mancala and enemy pits, but excluding the enemy Mancala. That's pretty wordy to basically just say we're going to make a move. Now that involves picking up all of the seeds out of a pit, right? So we're going to ultimately represent these ideas in code where I take all the seeds from here, I need to pick them up, and then going to drop them 1, 2, 3, 4, as such. Okay. I'm going to get ousted by the computer here. Of note, if we manage to, I'm going to refresh this, if we manage to hit the active player's Mancala, we need to be able to distribute one there. So for instance, these 4, I'm going to pick those up and go 1, 2, 3, 4, and I should drop one there because that is the active player's Mancala, right? Additionally, the active player gets to go again because the last seed being sown went into the active player's Mancala. More on that later. Okay, so we're going to perform a sowing action, blah, 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 blah. Precondition here, right? We need to precondition this pit because it's in a certain range. Easy enough. The way you would see it expressed on like the AP exam is effectively a number range, right? We're going to say that pit is going to be greater than or equal to 0. 0 is a possibility, but less than board.length minus 1, right? Why the minus 1? Well, board.length minus 1 is the other Mancala, right? This is not going to be a pit, and this is not going to be a pit, okay? So I need to basically express that this is not going to be a possible option as well here in the precondition. I've included basically everything but player 1's Mancala. So we're also going to say pit is not equal to board.length divided by 2. And maybe I would consider some clarification here. I'm going to put a comment in my comment, right? Board.length minus 1 is pit 12. Or maybe we're saying 0 is less than or equal to pit, which is less than 12. And here I'm saying that pit does not equal 6. Comment my comments. Okay. Last precondition, we are going to assume that the position that they pick has seeds in it, right? So the position that they pick is greater than 0. So there are some seeds there. Okay, we're going to return 1 if player 1 should go next. 2 if player 2 should go next. Let's get started. Okay. The first thing I recommend is stop worrying about player 1, player 2. Let's think about active player, enemy player, that sort of thing. I'm going to create some integers. Okay. I could initialize this to 0. I could say the active player is 0, but I'm going to have to override it anyway. So I'm going to take a similar approach to what we did with get seeds, where I'm going to assume one of the active players. Here I'm assuming the active player is 1. However, if, right, we need to basically see where we at in terms of the number range. If I'm somewhere in here, then we know it's player 2. If our pit is actually greater than player 1 Mancala, right? Here's player 1 Mancala. So if our pit is one of these, note that I know it's not going to be this because it's in my precondition. So all I have to simply say is if it's greater than this Mancala, then it must be player 2's turn. I want to put some braces here, more on that in just a second. If our pit is greater than player 1's Mancala, then our active player must actually be player 2 instead. Right, so I'm going to assume that the active player is 1. I'm going to do some logic to see, oh, maybe it's actually player 2. Now, some other variables I recommend is the active Mancala. Right, again, we want to take out player 1 and player 2. We just want to consider who is the active player, who is the enemy player, that sort of thing. So based on this, right, if I'm assuming that the active player is 1, I'm going to assume that the active Mancala is their Mancala. However, if my pit dictates it, I need to actually switch the active Mancala. We'll switch it to player 2 Mancala. That's why I left the braces here. I knew there was more that was coming. Likewise, we're going to care about enemy Mancala. The reason I know to come up with these variables, by the way, is that if you look, this is what it's talking about. Note that C should be distributed into the active player's Mancala. I need to know who the active player is. I need to know where their Mancala is at. In the enemy pits, but not the enemy Mancala. So the last one I'm going to plug in here is enemy Mancala. Okay. If player 1 is the active player, the enemy Mancala must be player 2. If it turns out that player 2 is the active player, then the enemy Mancala must be player 1. Okay. We're setting up these variables because for the rest of the method, I don't want to worry about player 1 and player 2. I want to worry about active player, enemy player. Now, I'm ready. I'm ready to pick up the seeds from a pit. Okay, I know what the pit is. I need to basically remove the seeds. I need to pick them up in my hand and start sowing them. So what I'm going to do is create a variable called seeds. This is my hand. I'm going to pick them up, right? Seeds is going to be board at pit. Okay, I need to show that those seeds are no longer in that position. So once they're in my hand, that's what this integer represents. The seeds are in my hand. I need to remove them from the board. So board at pit is going to be 0. That's it, right? They're in our hand. I'm ready to start sowing. I'm ready to start distributing into subsequent pits. Now, we're going to need a loop. I think you've recognized that. What kind of loop? Okay, we effectively have a set number of iterations in a way because we're going to iterate as long as we have seeds, but this is so clean to express this as a while loop. While we still have seeds, keep sowing, right? While seeds is greater than 0, we're going to sow. Okay, what I'd like you to recognize is that where pit is at. Let's say that I want to move this, right? My pit is 0, 1. So it's here. I've got my seeds in my hand. We're hovering above that pit. I need to move here before I distribute the next seed. So the first thing I want to do effectively is pit plus plus. Right? I've picked up the seeds. They're in my hand. We're going to move here. I'm ready to drop. So we effectively want board at pit to increase by 1. Okay. I have successfully dropped it onto the board. I need to basically remove it from my hand. That is seeds minus minus. This is the gist of it. Okay. Why don't we kind of test what we got so far? We're going to get some crazy numbers because there's a lot more to it, but I'm just going to return some false number now so I can test what I got so far. We ain't even used active player, enemy player, that sort of thing, but we can at least maybe move some seeds around. Okay, I'm back in my driver. I'm going to take out my test board. I'm going to bring back my default board. Let's get a reminder about what that should look like. And then we'll perform a move. All right, here's my initial board. And let's move pit 1. That guy right there. So I'm going to say, I'm going to take my Mancala game and tell it to move pit 1. That's going to cause a change. So let's see what our game looks like after that. Let's put in a new line here, maybe about plus new line. Put some spacing in there. All right, this is pit 1. I picked up those seeds. They're no longer there. And distributed, there was 4 seeds. I went 1, 2, 3, 4. Oh, that looks good. Okay, let's maybe do a different pit, right? Because this is the active player's Mancala. So I want to make sure that we are going to drop it in the active player's Mancala. Let's pick up pit 2 instead. And you see we went 1, 2, 3, 4, and we dropped 1 into the active player's Mancala. The reason why I'm even talking about active player Mancala is because we don't want to drop in the enemy Mancala, right? I want to be able to kind of wrap around and make sure that we drop into the enemy smaller pits, but not the enemy Mancala, right? So I'm going to take this 4. I'm going to move that boy instead. 0, 1, 2, 3, 4, 5. Let's move pit 5. We're going to drop into our Mancala as well as the enemy pits. Right? We see we went to our Mancala in the enemy pits. That looks pretty good. Okay. Now let's maybe overload. let's fill this one up with some seeds so that we're going to basically wrap around and maybe skip over the enemy player Mancala. Okay. So I'm going to bring back in my test board. I'm going to fill it with 4s. Although I do need to set the Mancalas to 0. It's this one. Okay, so I don't want this. I do want this. I'm bringing in my test board, but what we're going to do is kind of fill this one up with excess seeds so that we can go 1, 2, 3, 4, 5, 6, 7. And I don't want to drop 1 here. I want to go back here, which is 8. So let's put 8 seeds into that position. Okay, oh, I need to tell it to actually move that pit. Oh, I am. That's pit 5, right? So, as it stands right now, I picked up all the seeds from this spot, 8 total, and went 1, 2, 3, 4, 5, 6, 7, 8. So as it stands right now, I am dropping into the enemy Mancala. And I don't want to do that, right? Well, let's take a look. How are we dropping? Here's where I'm adding, and here is where like I'm subtracting it out, that sort of thing. So this is the actual, this is actually dropping it from my hand, right? Seeds minus minus into the board. I only want to do that if the current position is not the enemy Mancala. Okay, let's wrap that up into some braces and test it out. I'm going to execute this again. We're going to take those 8 seeds and, oh no, index out of bounds. Let's see what happens, right? We took those 8 seeds and we went 1, 2, 3, 4, 5, 6, 7. That's the enemy Mancala. So I want to basically go one more position, that pushes us out of bounds. So I need to keep this in bounds. The easiest way to do that is to use kind of an if statement, right? After we increase our pit, if we're out of bounds, I don't want to drop it. I don't want to drop a seed, right? That's what this represents, dropping a seed. I don't want to do that. Okay. The easiest thing here is to do like an if statement check to see, are we actually out of bounds? If so, let's wrap back around to this position. Okay, so if pit is greater than or equal to our board length, it should never be greater than, but if it is greater than or equal to our board length, what I want to do is set pit back to 0. Let's try this. All right, we picked up these 8 seeds. We went 1, 2, 3, 4, 5, 6, 7. I was here. That is the enemy Mancala. So we're going to skip that one. I perform an extra iteration where I move the pit one more. We then check to see. Our pit would be out of bounds at that point. It'd be like 13 or something, or 15, 14. The length of our board is 14, so 14 is out of bounds. So we set it back to 0, which is why we ended up placing a seed there. So this actually looks pretty good. Now, a big brain approach to this is implementing mod. Not necessary. I think most people would actually go this route and use an if statement, but the mod approach would say we would set pit to be what it is plus 1 modded by the board length. And that's actually going to keep us in bounds, right? If my pit is this last position, that's 13. I add 1 to it, I get 14. 14 mod 14 gives me 0, putting us back to where we were. That's why that approach works, and if I run it, you'll see that we get the same result. Okay, so that is sowing our seeds. We're sowing into the smaller pits, the enemy pits. We're skipping the enemy Mancala, but we are putting it into our Mancala, the active player Mancala. All right. At this point, I can actually possibly return something. I'm done sowing seeds. If my current pit is equal to the active player's Mancala, well, that actually means that we're done, and so we don't have to continue anymore. We don't have to worry about a capture. We actually know who should be returned. It is the active player, right? Another reason why these variables are super awesome. Okay, what is the scenario where that happens? Let's go back. I'm going to bring back in my main game. I'm going to take back out my test game, right? My starting move that you've always seen me open with when I'm playing the game is picking up this one and going 1, 2, 3, 4. And that ends in the active player's Mancala. That is pit 2, right? So we're going to go back to a default board. I'm going to move pit 2. We're going to pick up these 4 seeds and go 1, 2, 3, 4. I am distributing the last seed into the active player's Mancala. The active player gets to go again. That's what that check does. Okay, so if I'm still here, that means we're somewhere else. That means that we need to determine if there is a capture. So here is the hard part, and I need to remind you what a capture even looks like. Let's hop back to our project documentation. Oh my goodness, I had an example up here. Here we go. Here we go. A capture occurs if the last seed being sown would be distributed into an empty pit on the active player's side, and there are seeds in the opposing pit on the enemy side. Whoa, that's a lot. There's an example. Okay, we're going to go 1, 2, 3. The last seed being sown is on the active player's side, and there are seeds on the opposing side in the enemy player's pit. All of those seeds, the 1 that was here, the 5 that are there, are going to go to the active player's Mancala. They get to capture those. Okay. First thing I recommend is pausing the video and trying this yourself, but we're going to create an integer called opposite. It is, as you might imagine, the opposite position. Okay, That's actually somewhat kind of hard to figure out. But one thing to recognize is if I'm here at this point in the method, we're done sewing. Whatever pit is at, whatever that location is, that's where we stopped. Right? That was the last spot. Okay. So I need to basically determine what is the opposite position based on that. And there's lots of little formulas you can play with. I'm just going to go ahead and give you board.length minus 2 minus pit. Okay. Just hear me out. Just assume I'm right. Okay. So let's check for a capture. How do I know there's a capture? Well, for one thing, the last seed being sown is on the active player's side. That's a little bit hard to determine, maybe. What is a little bit easier to determine is, was that spot previously empty? If it was previously empty, keep in mind, I just got done sowing. I just dropped a seed in there. How do I know it was previously empty? Well, the amount of seeds is now 1. It was empty. Now there's exactly 1 there. Okay. Now the other thing I need to determine is this on the active player's side? Ooh, how do I know? Well, I know the active player is, and I know where their Mancala is at. Okay. So this determines the last seed went into what was a previously empty spot. I'm also going to do, oh, this is a weird formula. This is something my STEM kids came up with. Pit divided by board.length divided by 2 plus 1. What? All right. Let's take this formula. I'm actually just I'm gonna copy it for a moment. I'm gonna throw it into my document so that we can kind of translate it. Pit. Well, pit at this point is this location, right? That's 0, 1, 2, 3. Okay, so we got 3 divided by board.length. That's 14. Divided by 2. That's 7. Plus 1 is 8. Pit divided by 8. Okay, what is that going to give us? If we take 3 and divide it by 8, that gives us this number. Which is this is going to get truncated to 0, which is why the plus 1 is there. Let's maybe follow order of operations like adult. Board.length is 14 divided by 2 gives me 7, right? Then this division kicks in, apologies, which is going to be 3 divided by 7, which gives me 0. Blah, 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 blah. Okay. So that's going to get truncated to just 0, and then we add 1. Okay, why do we add 1? Well, ultimately, I'm going to take this formula and compare it to the active player. Okay, so the last seed being sown went into an empty pit. I'm now trying to determine, are we on the active player's side? And that's what this little formula does. Let's try a pit maybe on the other side, like this one over here. All right, the active player Mancala, well, player 1's Mancala is 6, 7, 8, 9. So let's take 9, throw that into the formula. We got board.length, 14 divided by 2. Sorry, 14 divided by 2 gives me 7. We're going to take 9, divide that by 7. That gives me a value of 1 because this is going to get truncated. We then add 1 to that and we get 2. And we would ask, is that equal to the active player? At which point, that would mean that we're on the active player side because it's player 2. Whew. That is quite the formula. Okay, so we dropped a seed into what was a previously empty spot. We're on the active player's side. The last thing I need to know and need to check for is, are there seeds on the opposing side? All right, we're going to go 1, 2, 3, and check to see, are there seeds on the opposing side? I gave you this sweet variable already, so all I need to do is ask, Are there seeds there? How do I know? Well, boarded opposite will be greater than 0. This is a capture. If the last seed being sown is on the active player's side and there are seeds on the opposing side. Okay, if that is the case, I need to take the seeds from these two spots and put them into the active player's Mancala. Okay, well, there's only one, right? There's only one in this spot because it was the last seed being sown. So that one's kind of easy. We can take boarded pit and make it 0. I need to remove the seeds that are there. I need to basically add one to the active player's Mancala. So let's take the active Mancala and set it equal to what it was plus 1. Okay. I also need to grab the seeds from the opposing side, which we've already determined where that location is at, and add those here. Right, so the active player's Mancala is going to be what it was, plus the seeds from the opposite side, plus the one seed from boarded pit. Now, you could do boarded pit like that, which I actually would in practice because that's what I'm trying to represent an abstract idea. The reason why you can get away with doing one is you know that there is exactly one there. So let's pick up the seeds, let's put them in there. I need to actually remove them from the opposite side here. So boarded opposite is going to also become 0. All right, so we're looking for the capture. We're performing the capture. I'm looking at this going, why is this gray? That's because it's a location, not the actual Mancala. That's the actual Mancala, boarded active player's Mancala. All right, this is a position. This is an index, not the actual element. Okay, so the last thing that ends up happening is if we're here, right, we need to determine whose turn it is. And this is big brain. You ready for this? 3 minus active player. What? Okay, if the active player was 1, if we're still here, basically the opposing player gets to go, right? I've already determined if the active player gets to go again, right? That's what this is. Active player goes again. If I'm here, it must mean the opposing player gets to go. Active player goes again, opposing player goes next. If the active player is 1, this will do 3 minus 1, so player 2 gets to go. If the active player is 2, it's going to be 3 minus 2, so player 1 gets to go. This is a big brain. I wish I could say I came up with it. Man, I've never seen subtraction so powerful. This is the move method. I agree, it's not easy. It's not easy to come up with this on your own. The biggest thing, I think, is taking out player 1 and player 2 Mancala and just thinking about it in terms of active player, enemy player, because otherwise you're effectively replicating all of this stuff. What we're going to do is pick up the seeds and put them in our hand. We're going to start distributing the seeds. Right here, we're changing our location, and then we're dropping a seed. After the loop is over, I'm done distributing my seeds. If we're at the active player's Mancala, the active player gets to go again. So we'll return that. If I'm still here, I'm going to look for a capture. That's what all this is doing. A capture will happen if the seed, or if the current pit was currently empty. Right, the last seed being sown would have been in an empty pit, and we're on the active player side, and there are seeds on the opposing side. We're going to pick up the seeds from the opposing side, as well as the current pit, which is only going to be 1, and put them into the active player's Mancala. I need to actually set those positions to 0 to show that they're gone, and then effectively the opposing player gets to go again. That's the move method. Let's try it out. Whew. All right. I want to set up kind of board states where, you know, we get to see, does the active player get to go again? And right away, oh, I can leave it on this one. Let's go with the classic. Right, what I really want to see is game.move is actually returning a value. So let's print that off. Okay, so we picked up, so the move, notice that the move happened. We picked up these 4 seeds and went 1, 2, 3, 4. The last seed being sown was in the active player's Mancala, so they get to go again. Okay, let's maybe try situations where we're setting up a board state. Well, let's just try it on the other side, right? If we pick up this one, we're going to go 1, 2, 3, 4, and then player 2 gets to go again. So that pit is going to be 7, 8, pit 9. I should get a 2 back out of this. Player 2 is the active player. The last seed being sown is ending up in their spot, and so they get to go again. Okay. Now I just want to try like a basic move. Like let's just move 1. Right. We're going to pick up all the seeds from here and go 1, 2, 3, 4. Then player 2 gets to move. It gets to go, and that's what we should see out of this move here. Right. Notice we moved seeds from player 1's side, but the last seed being sown did not end up into the active player's Mancala, so the opposing player, in this case player 2, gets to go. Similar situation, if I do 8 on the other side, player 2 is moving. The last seed being sown does not end in their position, so player 1 gets to go, in their Mancala, I should say. Now the capture. I'm going to set this up. Right, we're looking at 3, 0, 9. Zero to 0. Ten, 8, 4. 5, 13, 0. And then 1 and 7. I'm setting up this test case. We are going to test a capture. Let me comment out this one. I want to pick up the seeds from this position. That is position 0. Right? There's 3 there initially. Let's move pit 0. Right? We're going to pick up these 3 and go 1, 2, 3. We see that as 1, 10. The last seed being sown went into an empty spot, and there were seeds on the opposing side, which is actually this 5 here. I'll help you out with that in just a second. So we're going to pick up that 5, that 1, and those go into the active player's Mancala. Okay, what do I mean by I'm going to help you out with this? Well, there's a slight problem whenever we start getting more digits in our numbers, and here's what I recommend. Instead of doing just a single space, do a tab. Say what? This is the tab escape sequence, and what it's going to do is apply a tab in that spot. And so we're actually going to get kind of justified numbers here. We end up with something like this, where our stuff is spaced out. So now you can see we're picking up these 3 and going 1, 2, 3. And that is the opposing side, sorry, our justification. Or yeah, let me help you out with this again. I'm going to throw in a tab here so that it bumps this over so that they actually align. And so we're going to see our Mancalas off to the side. This is correct, I promise. There we go. We're going to pick up these 3 and go 1, 2, 3. And you see clearly that those are zeros there. Okay. I'm going to give you the GUI, show up to class, that sort of thing. And I'll show you how to basically use it to work your Mancala. But in terms of our video, this is it. I'm going to show you one last shot of the move method. and I will see you in the next one.